at top point and at bottom point of VCM by rod. So in place of string, the word is rod. So some changes are there. Again we require a diagram. So in this diagram, point A is the topmost point, point B is the bottom point, lowest point. So consider vertical circular motion by rod. We want to find out difference between tension at top point and bottom point. Let us find out tension T1 at topmost point, and then we find out tension at bottom point, that means T2. So point A is the highest point, or we can say that top point, and we are saying that in case of rod in VCM, minimum velocity V1 is 0. We are seeing this part in previous lecture. At this typical point, forces acting on the point A, that means particle at point A, are number 1, tension T1 directed towards the center of the circle. Similarly, weight mg directed in downward direction. So in other words, I can say that T1 and weight both are in the same direction vertically in downward direction, and therefore the resultant force will be addition of weight and T1. So we get F is equal to T1 plus mg. T1 indicates tension at point A plus mg. So we get total force, resultant force addition of these two things. And we have seen that whenever a body is moving in circular path, circular curve, then definitely a centripetal force is acting on the body. So we can say that this force is nothing but centripetal force. So the role of centripetal force is played by this resultant force. In other words, I can say that this force is equal to the centripetal force. So in place of F, we write this value T1 plus mg is equal to centripetal force. The standard formula is there, mv square upon r. So in this case, velocity at point A, we assume v1. We are saying that during VCM, velocity of the body changes from point to point. As it moves in downward direction, speed increases. As it goes in upward direction, speed decreases. And minimum at point A, maximum at point B. So here, V is equal to V1. So we get T1 plus mg is equal to m, 0 square upon r. V1 is 0. We are saying that at topmost point, in case of VCM by rod, it is possible, even though velocity is 0, VCM is possible. So in place of V1, we write 0. So we get T1 plus mg is equal to 0. So we get T1 is equal to minus mg. Transform this sign, we get minus sign. Equation 1. Simple mathematics is there. Now let us find out tension at point B, that means bottom point. Let us see how to find tension at point B, lowest point. So again, we require two forces. At this typical point, one force acting in downward direction, weight, vertically downward direction. We have seen that on every particle, every body, gravitational force acts in downward direction, nothing but weight. So weight is directed in vertical downward direction. Second, tension along the rod toward the center of the circle. So we can say that T2 and weight both are exactly opposite to each other. So I can say that the resultant force is nothing but subtraction of this and this. So resultant force T2 minus mg. So we get the resultant force F is equal to T2 minus mg. Again, we are saying that at this typical point, the body moves along circular path. So we can say that definitely there is centripetal force acting on the body. So I can say that this typical force is responsible for circular motion. In other words, I can say that this force is nothing but a centripetal force. So in place of F, we write now this value T2 minus mg. T2 minus mg is equal to m v square upon r, standard formula for centripetal force. Now in this case, v is nothing but v2. Velocity at this typical point B is different than velocity at this typical point A. So we call it as a V2, and we obtain expression for V2 in previous lecture. V2 is equal to under root 4gr. We have seen this part in previous lecture. So we get T2 minus mg is equal to m upon r in a bracket under root 4rg square After this, we hear T2 minus mg. Because of square, root sign is gone. So we get 4mrg upon r. So this r and this r get cancelled. Common term will be cancelled from numerator and denominator. So we get T2 minus mg is equal to 4mg. Now this mg on this side, it becomes positive. So T2 is equal to 4mg plus mg. That means 5mg. Equation 2. Our aim is to find out difference between tension at bottom point and upper point. So by equation 2 and by equation 1 we can find out. By taking subtraction between equation 2 and equation 1 we get T2 left hand side minus T1 left hand side of equation 1 is equal to right hand side of equation 2 5mg minus, and here equation 1 right hand side is minus mg. So minus in a bracket minus mg, the property of minus sign. Because of this minus sign, this become positive. So we get 5mg plus mg, that means 6mg. So we get difference between tension at bottom point and top point is 6mg. Question can be asked. Show that this difference is 6. So in our syllabus, the VCM is discussed by two ways. VCM by string or rope and VCM by rod. So if rod is there, we got such formulas, and if string is there, we get such formulas. So depending upon the word string and rod, there are examples are based. So at topmost point, velocity of the body in case of string is V1 is equal to under root gr. In case of bottom point, we get for string V2 is equal to under root 5 gr. Middle point, we get V3 is equal to under root 3 gr, and difference between tension at topmost point and bottom point T2 minus T1 is equal to 6mg. Similarly, in case of rod, VCM by rod, again 4 points are there: topmost point velocity, bottom point velocity, middle point velocity, and difference of tension at top point and lower point. So at the top point, in case of rod, V1 is 0. Here V1 is not 0. V2 under root 4g, here difference is there. V3 is equal to under root 2 gr, here V3 is under root 3 gr, and tension in this case and in this case the difference is same. So we should know the proper formulae while solving the examples. Small difference is there. If you understand the difference, it is possible to remember all formulas in the examination. Now we stop here. Next I will see remaining part of this chapter.